Good morning, George Huber from Anelotech and from UMass Amherst, University of Massachusetts. We're here at the ACS Spring Meeting in San Diego. Despite being California, weather is not so great, but we'll live with it. There's plenty of exciting science going on anyway. So George, thanks for taking the time to talk to Chemistry Views. Could you tell us a bit about your background and what you're working on at the moment?
Sure. So I'm a chemical engineering professor at UMass Amherst, and we're developing new catalytic technologies to take biomass and make fuels and chemicals from biomass. So our goal is to produce economic routes to make all the same fuels and chemicals from biomass that you make today from crude oil.
All right. Can you tell us a bit about which biomasses you're using and which platform chemicals and biofuels you end up on?
So there's a range of different biomass feedstocks we can look at. Our favorite feedstocks are the lignocellulosic biomass feedstocks, the feedstock that contains cellulose, hemicellulose, and lignin. There's three major types of lignocellulosic feedstocks we look at. One is woody biomass. So the trees, also the waste, the sawdust. The other is the agricultural residues, like corn stover, that's the leftover corn stalks on the field. There's also bagasse, that's the leftover sugar cane in Brazil. And then also the fast-growing energy crops that require very low fertilizer input, low water, and they're like miscanthus, switchgrass, and then we also look at carbohydrates as well and vegetable oil as well. So those are the biomass feedstocks. In terms of the chemicals we can make all the same molecules you make from crude oil. So we can make gas molecules that would fit into the gasoline pool, molecules that would fit into the jet fuel pool, molecules that would fit into the diesel fuel pool, and also we can make chemicals as well, including different aromatics, benzene, toluene, xylene, ethylene, propylene.
Wow, it's a really wide range of inputs and outputs that you have there. You have two talks today at the ACS. What are they about?
So one of our talks is on a process to make renewable aromatics and olefins called catalytic fast pyrolysis. This is a single-step technology where you feed wood into a fluidized bed reactor, wood or other agricultural residues. Inside the reactor you have a zeolite catalyst, and the biomass pyrolyzes, the pyrolysis vapors go inside the zeolite, and then out of the reactor comes your aromatics, your olefins. So it's a technology that we've licensed to a company called Anelotech, and it's moving forward to commercialization that we're very excited about. The second talk is a technology to electrocatalytically reduce biomass and make electrofuels. In this technology we take electricity and we also take biomass, and then we make liquid transportation fuels that could fit into the gasoline range pool. And so you can think of this as a way to store electricity and combine it with biomass and make liquid fuels.
All right. Well, these are very exciting results. We've read about them in several journals, and well, we also look forward to what you're working on for the near future. So maybe you could tell us a bit about what direction you're heading in now.
Well, thank you. Well, I think it's an exciting time to be in the field of chemistry, catalysis, chemical engineering. With high oil prices and the environmental challenges that are caused by our dependence on petroleum oil, there's lots of opportunities for advances in these fields. There's lots of advances to develop these new processes and to make them more economically viable by improving your yields, making better catalysts. We're continuing to move this forward. Our goal, really, we have four major goals. We want to make cheap renewable gasoline, cheap renewable jet fuel, cheap renewable diesel fuel, and cheap renewable chemicals, all from renewable resources.
All right. Well, it sounds very exciting. Thank you very much for taking the time to talk to Chemistry Views, and I wish you every success with your lectures today. Thank you very much, George Huber.
Thank you, Gwyn.